So I'll just talk to you guys about some networking. I'm not sure if it's something new. It is probably for some people, as I talked about it earlier in some meetings, and some people ask me like, hey, how do you use it and how does it work? So probably it is, I hope it is. So yeah, we all deal with networking. So between our customers and our platforms, between us and our carriers, between our points of presence, we all have like connectivity failures, or do we? So what to do about them, or better, not having to do anything about them. I mean, from a networking point of view, we are in a different world compared to like web hosting providers and just providers of any other stuff. As with us, uptime is just very important. Most landlines did always work, so people start to complain if they just can't make a call or the call drops out. I'm not used to it happening on like old ISDN or PSTN landlines that just always work, and with IP it's sort of different. Now we've got like platforms that are redundant, but you got to match it with the networking. Well, I don't have to explain you anything about quality, as that's like a network may be totally fine for use in web hosting or any other TCP based applications. As well, it just will retransmit, and as an end user, you're not going to just see anything of it. So yeah, well, I don't have to explain anything about quality, as just a minor networking glitch will just affect your call quality right away. But then we don't have the bandwidth requirements that like web hosting or access providers have. Voice is not just very bandwidth intensive. And well, we have to think of standing sessions. If you just do like, for example, host desktops and your connection drops out, it will reconnect. And with phone calls, it will not. If you lose like 20 seconds of audio, the call is going to hang up. So you just lose that phone call. So are there any solutions to it? If you are just using dynamic routing, and then there's the question, who of us are doing that? Would you guys use dynamic routing, run BGP or anything in their internal network like OTF or ISIS? So you see some hands.
Just BGP for us.
Just BGP. Most of the guys.
BGP.
BGP, LSPF.
The whole package.
The whole package.
Yeah, as ISP.
Yeah. ISIS, we don't need it. It's not that big.
Fair enough. Well, I would say from a networking point of view, just avoid going over the top, going over the internet, at least for your carrier or interpop traffic. So what are you guys using on that point, like MPLS or some VLAN on an internet exchange, or is it all just going over the top between pops? That's something I was interested in as well.
It varies for us. It varies a bit depending on the pop and who we're hosting it with. So we got a bit of a variance.
Okay.
Same with us. Some of them are present on the exchanges, the local geographical internet exchanges we're on, and others are over the top, which we don't like.
Okay. Well, then the best solution basically for networking issues is just to have your routing converge really fast, and that's a bit of an issue with most routing protocols, as they are designed just not to. And you need it for saving standing calls. And I just mentioned the sort of 20-second rule. Probably might be the 10-second rule. If you just lose 10 seconds of audio, all things are all it's all lost and hangs up. So you gotta be faster than that. So let's take this example network diagram. The 4 pops. I just went out from like in a European situation. So I have Amsterdam, I have Brussels, I have London, I have Berlin. Let's say this is all connected by MPLS or private VLANs between all POPs, and we all have all POPs just at least connected to 2 other POPs. So in like across. So let's say we're using BGP here. So all POPs are just connected by BGP peering between them. And if you run BGP, I don't have to tell you, you gotta have full mesh. So otherwise, you can't do it like within the same AS. So let's say you've got a carrier coming into Amsterdam, and you've got a customer in Berlin. The customer dial number in the Netherlands. So from a least cost routing perspective, you're going to route it out of Amsterdam. Let's say the primary route for it is going over Brussels. Or better said, between Amsterdam and Berlin is also a link. So let's say it's using that link as a primary link. So BGP is sort of tweaked to get the shortest paths aligned. You can do that in all sorts of methods with BGP communities or BGP AS depending if you like the more hacky way. So let's say a call has been established from Berlin to Amsterdam and then going out to a carrier in Amsterdam. And then all of a sudden your link between Berlin and Amsterdam drops out. Well, what's going to happen is BGP is probably going to notice it early or is not going to notice it early. And that's a bit dependent on whether your links are just point-to-point links. And I don't think any of us has that luxury of having like dark fiber and doing all the stuff on the fiber by yourself. So having your own optics on long distance and that sort of stuff.
We can dream.
Yeah, you can always. So it's always like MPLS, a VLAN, probably something like dense wavelength multiplexing. We use it on some occasions. But if your link drops out, it's going to be somewhere in the middle most of the time. So like a fiber cut, and you are only connected to the multiplexer at both ends. So your link will stay up, even though no traffic is going over your link. So then you've got the BGP hold down timer, and that's 90 seconds by RFC. And you can bring it down to like 2 or 3 seconds. I think 3 seconds is the lowest you can go with it. But that's not very good for stability reasons. BGP is quite heavy on as a protocol, so you might get just flattened links there. So there is a better way, and that's actually bidirectional forwarding detection. I don't know if any of you guys are using it.
Tell us more.
Okay. This is all you got to do for having bidirectional forwarding detection on your BGP links. So what it basically does is another protocol that just runs over your network, and it's just giving very small heartbeats to the other end in a very low interval. And if you can specify the interval, you can specify the boundaries of the interval in terms of, okay, how many traffic do I allow to be lost? Like this example says, okay, send every 50 milliseconds, send a BFD packet, and expect one every 50 milliseconds. And if 5 packets in row are lost, you consider your link down. And then it says on the BGP neighbor says fall over BFD. So if BFD does not receive the 5 heartbeats, it will just drop out the BGP session. And that's basically the way to have BGP, but also OSPF you can use just fine on OSPF or other routing protocols. Most vendors support it. And you can just have your, in OSPF it will be your adjacency, and in BGP it will be just your peering. Go down like after 50 milliseconds of lost traffic. So if you go back to the example, if that link drops out between Berlin and Amsterdam, it will notice within 50 milliseconds. And traffic will reroute either over Brussels or over London, depending a bit on how your network looks like at that point. But your customer won't notice. You will just have a faint click of just some lost RTP packets, but it's barely noticeable. You gotta have good ear to actually hear it. So your calls stay up between your POPs, and basically your customer is going to be happy. And there are some use cases. You can use it with your carriers, but yeah, then your carrier should be willing to run BGP with you or any other routing protocol. You can also do it for the customer last month. It was funny though, there was some talk on best practices on this part of KazooCon. And well, it was designed the way that standing calls would just fail. But you can use this to, if you have larger customers and especially customers with like call centers and ACDC, if you just drop your connection, you're going to have issues with ACDC also. So you can actually use this to balance over two end user connectivity lines, let's do DSL lines or fibers or whatever, and have the following situation just with a customer. You can do it. You can just say, okay, on my POPs I run little VRFs in my routers, and I use something like multi-protocol BGP to have those routes between all your POPs. That you gotta have like multi-POP redundancy, and then you do the same principle here, and you can do this on basically any router, simple Cisco 800 series, but you do just fine on this. And you can even do it over the top. You can even just say, okay, I don't have like a layer 2 connection for the end user DSLs. You can set up tunnels, and well, you'll have a little overhead with tunneling, but you can even avoid doing network address translation if you set it up really nice and have VRFs at your POPs with the routes for your platform in them, and then have a per customer VRF, a leak route between the VRFs, or have them all in one VRF and have a firewall in between or something. But you can just avoid network address translation, which gets cumbersome if you have like 100 endpoints or more on the customer side. You will start to see issues with network address translation easily, even though it's handled quite good in Kazoo, but still you can avoid it, and you can just build a setup with no downtime if a line fails. There are some things you should keep in mind. Basically, it's the sensible, don't bring too much Kool-Aid thing. BGP timers are there for a reason, so flapping is bad, and especially with large routing tables, you can easily just kill the CPU of your router. It's on quite the low-end boxes, it's still all CPU bound anyway. It's sometimes even single threaded. So with large tables, you're gonna end up with your network being affected by high CPU usage. So you got to take care of. Don't use it with large routing tables. If you are to do something like this example, you will want to isolate your domains. So you are basically making a routed setup from your customer to your platform. So take care of security, put a firewall in between, and even customers from one customer to another, you don't want actually have them their networks talking to each other. Your phones are directly exposed at some point, so yeah, you got to take care of firewalling and stuff. But that's obvious, but just want to mention it. And you will want to watch your timer. So this is as low as you can go, 15 milliseconds. But you will only want to do this on like a really, really dependable connection. If it's just pretty stable, you can do so. But if there is some jitter, if there is some variance in jitter, you probably want to go with higher timers. So this is in milliseconds, so like 15 milliseconds is really low. We usually use like 200 or 300 milliseconds, and you still won't notice. So you gotta balance your timers with the sort of network you have. And obviously, if you are doing it over the top for a customer, your timers will need to be higher. If you can have queuing, you can have congestion on some point of the underlying network, and you don't have any control over it. So the better option is to do it over just a layer 2 circuit you totally control, and then you can do QoS and anything. But it all depends a bit on customer budget, and you can go for a low-cost solution that's just not dropping calls or losing registrations if one of the provider carriers goes down. So basically, that was my story. Any questions on it?
Do you have to have the automated failover running on both devices?
Both ends, yeah.
Okay, so you can't do it with your transit, IP transit upstream. It has to be on your client's gear, your own interzone gear.
Yeah, you can totally do it with upstream transit, but they have to do it as well.
Okay.
So it's basically in Cisco you say like show IP BFD neighbors. It says, okay, I see the other end, and packets are being exchanged. It's a two-way thing. So they send a stream and you send a stream, and both ends just verify if everything is there or should be there. And if it's not, just drop the BGP session or whatever protocol you're using. So that's
cool.
That's it. And probably I'm not sure if you want to do this with the transit carriers. Tables are larger at that point. If you're running full table, you might end up with larger tables, and you'll probably just want to sit out a small brief glitch and not drop the peering. That's what the timers are for. So if you just miss a couple of heartbeats, you don't want to drop the peering if the other side is still there. In fact. But if not, then then you have to. But you probably don't want to do it with a live routing table, unless you choke your CPUs.
And the reason why the call continues to function is because it's a UDP stream.
Yeah.
It doesn't really care what route it takes as long as it gets to its destination.
Yeah, but that will work for TCP stream also, as source and destination will not change. It just takes another path. So it will work like for MQP connections also. You don't want to drop them if not necessary.
Yeah.
So it just helps. Just greatly helps in your platform stability as well, because you don't have any. If you don't have any events with disconnecting, connecting, and stuff going on, it's just better. So.
Are you running BGP at each of your POPs?
Yeah, at this point we have. Yeah.
Okay. We are as well. You guys
Not all our POPs.
a mix, right? Yeah.
But we don't have like a large number of POPs. You guys way more than we have. So the challenge is harder for you.
Yeah, and we have some smaller POPs like our Melbourne one, where it's not big enough for us to put a bunch of our own hardware in there, so we're running off of someone else's stuff, and networking just becomes a little bit more.
Yeah,
like the data center there and the people doing it there have to be able to do it. And
yeah, even within Canada, with the geographical spread, it'd be something worthwhile looking at if there are multiple routes, east-west, because we find Vancouver to Toronto, that route is not as stable as it should be.
Really?
Yeah, that's not our MPLS or private carriers. About a week, maybe 5 times. There'll be a little blip, and we notice it. Yeah, every time.
yeah, it's for maintenance. It's also a good thing for maintenance. You can just drop a route, and your calls will still be there. There are, and also on the customer side, you can just say, okay, I see this flapping, or I see this maintenance coming up. I'll just disable one of the DSL lines, even though there are still ongoing sessions, ongoing calls. It just also keeps working. Nobody notices, and that's a good thing in maintenance.
Yeah.
So, any other questions?
Okay, thanks very much, Remco.